So today we're going to do ray diagrams, which are very similar to the curved mirror diagrams we did before, only this time we're going to use lenses. And in lenses, we're going to draw 3 beams of light. We'll see where they cross, and that's where our image is going to be found. Now, you need to remember while doing these diagrams that the light is going to go straight through the lens. So, not like the mirror where it bounced off the mirror. Instead, it's going to go to the lens and through the lens because remember, the lens is made out of glass. So, we have 3 rules. We'll start with a converging lens. Now, remember, in a converging lens, we're talking about the kind of lens that would look like this. So it would look like this. It would have a curve, right? This is what a converging lens would look like with a big fat middle and pointy ends. And we don't want to try to draw this shape since it's really hard to tell where the center of the shape is. And one of the things we need to find is the optical center, the very center of the shape. So instead, what we do is we draw a straight line and then we just represent the type of lens by the tip. So we show that it has pointy edges like this by just putting these little arrows on the end. So our 3 lines, pretty straightforward. Line number 1, it's going to go from the top of the object, just like we did in the past, into the lens. And when it hits the lens, it's going to go down through the focal point. Remember, this is a converging lens, so it converges or brings light together. So that is rule number 1. Straight in, always starting at the top of the object, always, always straight into the lens, down through the focal point. Rule number 2 uses what we call the secondary focal point. Now remember, when we deal with a lens like this, because it's glass, light can come from the right or from the left, which basically means it has a focal point on either side. The rules utilize this. And rule number 2, you go through the top of the object, through what we call the secondary focal point, or the focal point that's on that side, and then straight out. So parallel to what we call the principal axis, this line here. So straight out and parallel to it. Rule number 3, very straightforward. This is the one that uses the optical center, which I've tried to mark with an O here. The optical center is actually the crosshairs where the lens meets the principal axis. So I'm going to go through the top of the object, as always, top of the object, always, 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 and straight through the optical center. The way the optical center lines up is that the light will hit the edges of the lens at 90 degrees and therefore actually not bend. It will continue going in a straight line. So those are the rules for a converging lens. Diverging lenses have similar rules. Remember, a diverging lens would look more like this, right? It has this classic shape, and because of that, the ends are thicker than the middle, and we try to represent that with these ends here having a triangle on the end in order to create that thicker end than the middle. So 3 rules, very similar. Rule number 1, I'm going to go straight in from my object. But instead of going down through the focal point, remember, this is going to reflect light up and spread light out. That's the diverging part of the diverging lens. So you want to line up your focal point and where this hit the lens and go straight out. Now, you're not going to draw that first part. I kind of have to with my arrow. What you're going to do is line up your ruler like my line has been, but you're only going to draw this bit here. That's going to be rule number 1. So straight in, then line up this focal point with where you hit your lens and go straight out. Rule number 2. Rule number 2 also uses the secondary focal point. In this case, we're going to start at the top of the object, as always, and we're going to line up our ruler with that secondary focal point. And when it hits the lens, it will go straight out. Now, we actually want to back that off because we actually don't want to draw that last part, right? Because what will happen is the light will go towards that secondary focal point, hit the lens, and straighten out. Third rule is the same for both types of lenses, so it's very easy to remember. You go from the top of your object straight through the optical center, because no matter what the shape is, it will always hit, if it goes through the optical center, the very center of the lens, it will hit at 90 degrees, and it won't bend at all. Okay, we know our 3 rules now. We want to utilize them, and it just means putting them on the diagram all at the same time and seeing where they cross. So This is my first example. I'm going to start top of the object, straight in, down through the focal point. Line number 1. Rule number 1. Object, or rule number 2, top of the object, always the same place, through the focal point, the secondary focal point, and then we're going to go straight out so that this line is parallel with that principal axis. Third rule, top of the object, straight through the very center, the optical center of the lens where this crosshairs happens. You'll see the 3 lines now cross. That's very nice. I can now draw in my image. Always draw your image in, right? You want to draw it in to show you understand this is where it's located, and then you will write your characteristics. So I can tell that this is inverted. Oh, I'll start with the smaller, and its attitude, inverted. Its location, well, that seems to be closer. And if I had a screen, I'd move the screen back and forth until it focused here. I also know all inverted images are always real, so I can state my 4 characteristics quite easily. So that's my first example. In my second example, I'm going to just move my arrow, right? This is just about practice. The more you do of these, the better you get at it, right? You get used to those rules, they get embedded in your head, and then you remember them when you're doing your evaluation. So straight in from the top of the object, down through the focal point. Nice, no problem. Rule number 2, top of the object, through the secondary focal, and then straight on out. Lovely. Rule number 3, top of the object, optical center. Remember, if you're watching this and you're trying to draw these diagrams, pause whenever you want to in order to draw your diagrams, draw your lines in, right? And then just hit play again when you're ready to move on. I draw in my nice little object or my image. There's my image. And if I've done this perfectly, this should be the exact same height as this. And this distance should be the same as this because I actually put my object on twice the focal point, which always creates the same characteristic. So my characteristics should be same size, should be inverted because you can tell it's upside down. Remember that these meet at the top of the image, and if that's below the principal axis, I will draw the arrow down to that point. Definitely same distance. And I would also say that that is real because inverted images are always real. And that is where I would have moved my screen back and forth until my image appeared on that screen as focused. Okay, we'll try our next one. Moved my arrow even closer. This should change my characteristics just slightly, but it doesn't change the rules. Rule number 1, straight on in, down through the focal point. Rule number 2, through the secondary focal point, then straight on out. I'm going to extend that first line a bit. If this ever happens, just make your line longer, right? Take your pencil, make the line longer, not a problem, right? You want to see them cross. And rule number 3, top of the object through that optical center. And they kind of cross. Mine's not perfect this time, but you can tell where they should cross. We're going to put our arrow there, right? So there's the top of the arrow, and I'm going to draw it all the way back to the principal axis. And then I can describe my characteristics very easily. This one is definitely larger. Larger. It's definitely inverted. It is farther away now, and it is real. I would put my screen there and I would get a nice focused image, and inverted images are always real. Couple more to go. We're still in the converging lens, but this time I've put my object right on the focal point. And if you did this in a lab, you would find you had some issues, because if you put your first one in, straight in and down through the focal point, excellent, no problem. Rule number 2, I can't draw because I can't go through the secondary focal point, the top of the object, and get anywhere close to this lens, so I can't even draw it. And rule number 3, when I do draw it, you'll notice all of a sudden I get parallel lines. Those parallel lines mean that they will never cross. And that's why when you put something on a focal point, you don't get an image. It also makes sense that when you think about it, you are changing at this point anything out here farther from the focal point, you're going to be getting a real image, and anything closer, it's virtual. So this is also where it changes from one to another. And that's because it goes parallel and then they start to cross on the other side. So this I would just write no image parallel beams. Because your beams of light never cross, you can't get a focused image. Okay, we move on to our next one. Now we should be getting a virtual image. We know that because we're closer than the focal point. I've moved over and now should be getting a virtual image. I'm going to use the same rules though. Light goes straight in, hits the lens down through the focal point. Rule number 2, secondary focal point, top of the object, no problem, and straight out. Now you'll notice these two beams aren't going to cross, but they're also not parallel, so we'll be able to get an image. And our third one, same as always, straight through the optical center. What I want to do is now trace these back. I want to trace back and see where do these meet. So I want to trace these back, the ones that went through the lens. None of these that went through the lens. So I'm going to trace this one back. I'm going to trace this one back. And then I'm going to trace this one back. And they should cross over here, no problem. Now when I draw in my image, you'll see that this is the top of my image over here, which means when I go down to the principal axes, I now have an upright image. So I would call this obviously larger. I would say this is upright because it's now upright. I would say it is farther than the original object, and it is definitely virtual because I had to trace it back to find it. Remember, you'd be standing on this side looking through this lens and seeing this image from the other side. So you'd be over here looking through, and this is what your eye would actually trace back and locate your image. And you also know if it's upright, it must be virtual. There we go. So those are our ray diagrams for converging lens. I'm going to switch to a diverging lens. Remember, you should always, before doing one of these diagrams, first thing you have to do is look to see what kind of lens am I working with here, because you should always look at the ends. Otherwise, you might draw the wrong rules on the wrong diagram, and then you'll get a strange and not correct answer. So rule number 1, though, oops, I'm still on the dotted. Let's get rid of him. I want a nice solid line. So rule number 1, straight on in. And then it's going, instead of going down, remember diverging lenses make light spread out. So I'm going to go up and I'm going to line up this point with where I hit the lens. Remember, when using your ruler though, you will actually not draw this bottom bit, right? You'll just line it up with your ruler so you get the angle correctly. So that's rule number 1. Rule number 2, remember, I'm going to aim at my focal point, but when I hit the lens, I'm going to go straight. Again, you're not going to draw this last part. You'll just draw what looks like this. So you're going to aim it. So it aims at the focal point. When you hit the lens, go straight out. So you're parallel with your principal axis. Rule number 3, though, doesn't change from any lenses, all straight through the optical center. You will notice they don't cross on this side, and they shouldn't. Remember, all diverging lenses only create virtual images, so you'll always have to trace these back because you'd always be looking through the lens at your object and seeing the image on the other side. So I will trace this guy back, right? And I will trace this one back, And in this case, I don't have to trace the third one back because it already crosses. Instead, I can just draw in my image right here. It'll be a tiny little arrow, but it's still an arrow. It is above the principal axis, so it is upright. And I can just now name that it is smaller, it is upright, it is closer than the original object to the lens, and it will be virtual because I had to trace it back in order to see it because I'd be looking through and my eyes would trace it back and see it. No screen, and upright is always virtual. We'll do one more of these just to make sure we're good at it. So remember 3 rules for diverging, because I look at those tips, I see it's diverging. I'm going to go straight in, but with a solid line. Straight in. I've done that twice today. Then instead of going down, I'm going to go up. I'm going to line up with this part, right, with this secondary focal point. So it goes up. I'm going to draw my second one in, aim it at my focal point, but when I hit the lens, it will go straight. Remember, you don't need to draw this bottom part. It's just for lining it up. And rule number 3, straight on through the middle. Again, they don't meet on this side, but they can be traced back. So they meet on the other side. So I'll trace this one back. Remember, you're only tracing the light that passed through the lens. That's how you know which ones to trace. And you can see where they cross here. I'm going to put in my image. I get a small upright arrow. So just like the other one, remember diverging always get the same characteristics. It's smaller, it is upright, it is closer, and it is virtual. So I can name my characteristics. Basically how we do these diagrams. They just take some practice. That's all they take. Keep on practicing.